Today we're going to be talking about the inverse trig functions. For these notes, there's a couple handouts that you're going to need. You're going to need the one that has these graphs, and you're going to need the one that has the 3 unit circles. So we have dealt with inverses previously. So there's 2 different ways I want you to think about inverses. We're going to look at inverses algebraically, and we're going to look at them geometrically or graphically. So algebraically, we switch x and y. Graphically, we switch the x and y coordinates, which means our graph is reflected in the line y equals x. So let's first look at this algebraically. If I have the function, say y equals sine of x, the inverse, we would switch the x and y, so we'd have x equals the sine of y. Well, the thing we have for this is inverses. So this is going to be sine to the -1 of x. So I want to talk about the inputs and the outputs of these 2 different equations. So for sine, what we do is we take the sine of an angle. Okay, and it doesn't always necessarily represent a physical angle, but we take a degree, a sine of 30, a sine of pi over 4. The input is the angle. What we get out of that is a linear measurement. Okay, it's the ratio of geometrically opposite over hypotenuse. On the unit circle, it's going to be the y value, which represents the height at that time. For the inverse that is switched, what we're going to input is the linear measurement. So like root 3 over 2. What we're going to get out as our answer is the angle. Okay, let's talk about some notation. So we have the notation that really was invented by Texas Instrument of y equals sine -1 of x. This isn't great notation because this -1 isn't actually power. So if, say, we had sine squared, that's equal to the sine of x squared. But sine -1 of x does not equal 1 over sine of x. Okay, those are not equivalent. So we do have alternate notation, and really the notation that is the original. Okay, instead of sine to the -1, you're going to see arcsin x. These are the same exact thing. They say the same exact thing, it's just different notation. This is inverse sine, this is inverse sine. We will use both. We'll see arcsine, you'll see sine inverse, just understand they're the same thing. Okay, so I have 3 statements here involving sine and a -1 exponent. So this first one, sine to the -1, is again our notation for the inverse. So it's equivalent to y equals arcsine x, and this is the inverse. Okay, if it's written like this is going to be the reciprocal. So this would be y equals 1 over sine, which would be cosecant of x. So this is the reciprocal. Okay, this last one If we don't have the parentheses around it, the -1 is only going to apply to the x. So this would be the same as sine of 1 over x, x to the -1. So this would be sine of the reciprocal. Now we're going to take a look at this graphically. Okay, so let's do a couple cycles of sine. So there's sine, we continue it. Okay, so there's a sine curve. If we were to reflect this over the line y equals x, the line y equals x is going to be about here. This whole thing is going to get flipped up. Okay, so it snakes up the graph, and the issue here is this is not a function. Okay, so what we need to do to create an inverse function is to restrict the range of values. Okay, so on this handout we have the different graphs of the inverse trig equations. We're going to make it so that we have a function. Okay, so if you have a highlighter, this will be helpful for you. Okay, so arcsine, we have all these different values, and we know it's going to repeat, just like sine repeats over and over and over again. So to make this so that it is a function, we're going to pick a part of this graph, which goes from -1 to 1, but doesn't overlap. So to do that, we're going to start this graph here, and we're going to stop here. So I'm going to highlight just this part of the graph. That yellow highlighted part of the graph is a function. It passes the vertical line test if I take away everything else. Okay, so this highlighted part of the graph, your book uses a capital letter to distinguish the difference between the non-function and the function. So we will use that, but that's not necessarily always the case. It's understood that if we're talking y equals sine inverse, that we're talking about this little piece. If you graph sine inverse in your calculator, it's just going to give you this part of the graph. Okay, so I'm going to talk about the domain and the range of this highlighted area. The domain is the set of x values. So that's going to be from -1 to 1. The y values go from -π/2 and these are inclusive to π/2. So now let's say I want to know what the sine inverse of -1 is, or +1. Okay, so it should be pretty clear from this graph that my 1 is at π/2. So my answer here is going to be π/2. But what if I did something like √3/2? Okay, we would need to use the unit circle. Okay, so we have 3 unit circles here. This first one, we're going to adjust for arcsine. Okay, so the unit circle has all the different trig values, and if I want to find the sine or cosine tangent of anything, I can find it on this unit circle. The inverse, however, there's only one answer to this question. There's only one value where sine inverse is √3/2, but it's going to occur more than once on the unit circle. So what we need to do is change our unit circle to reflect this highlighted area. Okay, so we're going to highlight from -π/2 to pi over 2. And those are going to be the only locations we're going to look at for sine. Okay, well, pi over 2 is up at the top of the circle. Negative pi over 2 is down here at the bottom of this circle. So I'm going to go ahead and highlight just this half. Okay. So this is negative pi over 2 to pi over 2, but it also includes values that we don't want. So what we have labeled here would be if I had highlighted this area and then from 3 pi over 2 to 2 pi. Okay, those aren't the angle measurements that we want. We want the angle measurements from negative pi over 2 to pi. So what I'm going to do is I'm going to cross off 2 pi, 11 pi over 6, 7 pi over 4, 5 pi over 3, and 3 pi over 2. Those are not a part of our inverse function. I'm going to replace them with their negative equivalents. So this would be negative pi over 6. This is going to be negative pi over 4. This is going to be negative pi over 3. And this is negative pi over 2. So now this highlighted area matches our highlighted area here. So now when I'm asking a question like, what's the sine inverse of root 3 over 2, you're going to find the y value that has root 3 over 2, which is going to be pi over 3. What if I wanted arcsine of negative root 2 over 2? Okay, so we're looking for the y value to be negative root 2 over 2, which is going to be right here. And I know this unit circle is a little tough to see, but you should know what these values are from your big unit circle. So my answer is going to be negative pi over 4. Okay, we know that sine is negative root 2 over 2 really an infinite number of times. On the unit circle, that's at 5 pi over 4 and 7 pi over 4, but our function value is going to be negative pi over 4. All right, so now we're going to do a similar thing with cosine. But with cosine, I can't highlight from negative pi over 2 to pi over 2 because that wouldn't be a function. But there's a pretty natural selection, which would be from here to here. So from 0 to pi. So here, my inverse function would be arc cosine or cosine inverse of x. This one's domain is still from negative 1 to 1. Its range, the y values go from 0 to pi. I'm just noting I put an x there. Okay, so let's put this on our unit circle. So the unit circle, our second one here, this is going to be arc cosine. So 0 to pi is the top half of this circle. So I'm just going to highlight from here to here. Okay, and these angles are good. They go from 0 to pi with the exception of 2 pi. I want to eliminate 2 pi. So now we can add questions. So let's say I want the cosine inverse of, let's go ahead and do 1. Cosine inverse of 1. So we're looking for where the x value in the highlighted area is 1. And if you look at each of the x values, they're all the numbers from 1 to negative 1, just represented once. So this cosine inverse would be 0. Not 2 pi, because 2 pi is not between 0 and pi. It has to be the 0. Okay, what if I want the arc cosine of a negative 1/2? Well, that's going to be here. So we get an answer of 2 pi over 3. Okay, let's repeat this for tangent. Okay, so this would be my graph of arctangent. So if I wanted to select a convenient function value, because it does not pass a vertical line test, what we do is we pick this middle guy. So this is going to be called arctangent or tangent inverse. Okay, its domain is all real values. Okay, we can plug in any number we want and get a value out. This one's range is going to be from negative pi over 2 to pi over 2. This is non-inclusive because tangent at pi over 2 and negative pi over 2 is undefined. The inverse is undefined. You won't ever get pi over 2 or negative pi over 2 as an answer. Okay, so now let's look at our unit circle. Okay, so we're going to make an equivalent thing here. So this one's going to match the sine domain, or the range, sorry. Okay, so it's from negative pi over 2 to pi over 2. So it's this side. Okay, just like I did on the sine, I'm going to get rid of anything that's not between negative pi over 2 and pi over 2. Okay, and replace this with negative pi over 6. This is negative pi over 4. This is negative pi over 3. And this is going to be negative pi over 2. The next thing I'm going to do is actually add the tangent values to this, because we have the sine and cosine in the x and the y. And really what we're doing here is just making this a useful document so that I can just do the inverse functions easily. So this tangent is y over x, so tangent is 0 over 1 here, so it's 0. 1/2 over root 3 is going to reduce to root 3 over 3. Root 2 over 2 over root 2 over 2 is 1. Up here we're at root 3, and then at the top of the circle, tangent is undefined. Going down, this will be negative root 3 over 3, negative 1, negative root 3, and undefined. So now let's do some examples here. So let's say I wanted the tangent inverse of negative 1. So we find negative 1 here, go across to our newly labeled negative pi over 4. So I want arctan root 3 over 3. So root 3 over 3, we get an answer of pi over 6. So if we have these highlighted unit circles, evaluating these are very easy. Let's do some additional examples. Okay, so we have the cosine of the sine inverse of negative 1/2. So we're going to work from the inside out. So the inside, we're going to go to the highlighted unit circle and find where the y value is 1/2. So I go here, we find the y value is negative 1/2 is negative pi over 6. Now I'm evaluating the cosine of pi over 6. So for the inverses, you're going to use these graphs. For just our regular plain old trig functions, we're going to use our good old unit circle. So cosine at negative pi over 6, which is still going to be here at 11 pi over 6, the cosine there is going to be root 3 over 2. So we have sine inverse of the cosine of 4 pi over 3. So starting on the inside, we're evaluating just a regular old trig function. So I'm going to take out my big unit circle, look at 4 pi over 3, cosine there, the x value is negative 1/2. So this is going to be the sine inverse of negative 1/2. Now I'm doing the inverse, so I need to go to my little unit circles on the highlighted area, find the one and only one location in the highlighted area where my y value is negative 1/2, and evaluate negative pi over 6. Okay, so again, if we're finding sine, cosine, or tangent, our answer is a linear function. If we're finding an inverse, our answer is an angle. Okay, so you might try doing this on your own. Pause it, see if you can get the right answer. Start on the inside. Sine of pi is 0. Okay, we go to the pi, go find the y value is 0. Tangent inverse of 0 is 0. So next one, we'll do sine inverse of the sine, 3 pi over 2. Okay, on our unit circle, big unit circle, we find 3 pi over 2 and find the y value there. -1. Now we go to the little unit circle and find where the y value is -1. Well, it's at the same exact location, but what we're going to call this is not 3 pi over 2. We're going to call this negative pi over 2 for the inverse. Okay. So the key to inverse functions is understanding that the ranges are limited, so you're only going to get out particular answers, one and only one answer.